Okay, so I just made videos on -1 times -1 equals +1 and 0 times any number is 0. And another one that I like to go over on the first day class and almost every class for the past decade is the FOIL method. So, I write the FOIL method on the board, which is exactly written right now. And I ask, simple question, why is it true? And it actually boggles a lot of people's minds. Like it's something they never even considered asking, and I think it's a very natural question. Why is it true? And, you know, the responses are just different because generally nobody ever asks, right? In addition, nobody that I've taught has ever been in a class where one of their friends or, co-students have actually asked why this is true when they were taught it, which is awkward, right? Um, so no one's ever asked. And in addition, just the consideration seems to be mind-boggling for a lot of students. So we're going to make this simple, not mind-boggling. We're going to just do it, right? And so I'm going to start with, a plus b, times c plus d. And I'm going to try to, get the FOIL method. And just for clarity, this is the first, outside, inside, last. So it really is a FOIL method. You can double check, make sure. So what I wrote is a standard form of the FOIL method using A, B, C, and D. And you can use X, Y, Z, whatever you want. It doesn't matter, W, it's no problem. The FOIL method stands for first, outside, inside, last, when you multiply two binomial terms. And it works, it definitely works. So the question is why? So looking at a plus b times c plus d itself, really, we have no way to understand how to multiply this. But we do have something similar, the distributive property. So I'm going to let x be equal to c plus d. Okay, and so what happens is, so after we let x equal c plus d, what we get is a plus b times x, very simply. And that's it, right? And, at this point, I was a little confused on how to multiply it together, but here it's very straightforward and simple. It's just a distributive property. So this is equal to, ax plus bx. Hooray! And this is cool because, first of all, I made a little bit of progress, but I know what x is. X is, c plus d. And I put the parentheses around just to minimize ambiguity because it was a direct replacement. To be honest, you didn't need the parentheses because c plus d is a sum of two numbers, so x is just the sum of two numbers. But I think it's most appropriate, and technically it's more precise, so that's why I wrote it in that manner. So, substituting that back in, I get a times c plus d plus b times c plus d. And this is really cool. Why is this really cool? Well, this can be evaluated using the distributive property, and this can be evaluated using the distributive property. And, once I do so, you're going to see that the FOIL method is essentially, it follows directly from one substitution step, which is right here, followed by distributive property applied twice. You could say it's applied 3 times. I'm going to say twice. But right here, what I have is AC plus AD plus BC plus BD. Is this exactly what I needed? It is. So therefore, this is equal to what I needed. And that is the proof of the FOIL method. That's where it comes from. And you could write it in your own way, and you didn't have to substitute C plus D as X. You could substitute A plus B, but then you're going to have to rearrange terms. So what I did was actually quicker. It was cleaner. Anyway, thank you very much for watching.